Hello? It is an ordinary source of light produces unpolarized light. Ordinary source of light produces unpolarized light. In that unpolarized light, light vibration is all possible directions perpendicular to the direction of propagation of light. This arrow gate indicates direction of propagation of light. Direction of propagation of light. Okay, so this is ordinary source of light produces unpolarized light. Why? Because in that light vibration is all possible directions is a perpendicular to the direction of propagation of waves. Okay, it is the unpolarized light. Unpolarized light. Okay. This unpolarized light is made to pass through a certain crystal, like a tourmaline crystal. Optic axis of a crystal. This unpolarized light is allowed to pass through this tourmaline crystal. That light vibration come out from the tourmaline crystal only one particular direction, like this. See, here light vibration in all possible directions. That is, unpolarized light contains light vibration all possible directions. This unpolarized light is made to pass through the tourmaline crystal. See, emergent light from the tourmaline crystal, light vibration only one particular direction, see, which is parallel to the optic axis of the crystal. This is the crystal. So, this light vibration only one particular direction. All other vibrations from the unpolarized light are restricted by the tourmaline crystal. So, light beam come out from the tourmaline crystal. That light is said to be plain polarized light or polarized light. Polarized light or plain polarized light. See, using the crystal, we can make to change the unpolarized light into polarized light, because unpolarized light is allowed to pass through the tourmaline crystal. That light vibrations come out from the tourmaline crystal only one particular direction, which is parallel to the optic axis of the crystal in a plane. That's why that emergent light from the tourmaline crystal is said to be plain polarized light. Is plain polarized light. So, ordinary source of light produces unpolarized light. Unpolarized light is allowed to pass through the tourmaline crystal. That emergent light from the tourmaline crystal, that light vibration, like electric field vibration, only one particular direction, which is parallel to the optic axis. That light is said to be plain polarized light or polarized light. Okay. Now, in this session, we got to discuss about how we convert unpolarized light into polarized light. There are several techniques are used to convert unpolarized light into polarized light. But in our syllabus, we have a fourth technique to convert unpolarized light into polarized light. First one technique. Polarized light. Polarization by selective absorption. It is one of the technique to convert a unpolarized light into polarized light. Second technique, polarization by reflection. It is one more technique we use to convert an unpolarized light into polarized light. Third technique is used to convert unpolarized light into polarized light, polarization by double refraction. Then fourth technique we adopt to convert unpolarized light into polarized light, polarization by scattering method. These are the four techniques we use to convert unpolarized light into polarized light. Polarization by selective absorption, polarization by reflection method, then polarization by double refraction method, polarization by scattering method. In this method, we used to convert unpolarized light into polarized light. Okay, we go to see first technique, that is polarization by selective absorption. Selective absorption. It is a first technique we use to produce unpolarized light into polarized light. Okay. Selective absorption is the property of a material. See, any one material, it possesses a property of selective absorption. It is a material. This material have a property selective absorption, which transmits the electromagnetic wave whose electric field vibration in a particular direction restricted by all other vibration by that material. So material have a property of selective absorption, in which transmits the electromagnetic wave whose electric field vibration in a particular direction in a plane is restricted all other vibration by that material, because that material possesses a property of selective absorption. It selects the particular wave, absorbs all other waves. So which means that material which transmits a electromagnetic wave whose electric field vibrations only one particular direction, all other vibrations in that wave are restricted by this material, because that material possesses a character selective absorption, or a material has a property of selective absorption. Okay. Next, that material is called polaroid or polarizer. Polaroid or polarizer. So, polaroid is a material which is used to transmit the electromagnetic wave of electric field vibration in a particular direction in a plane, restricted all other electric field vibrations by that material, because that polaroid material have a character selective absorption. Okay, or that polaroid, or it is also called polarizer. That material which have a selective absorption property, which transmits the electromagnetic wave of electric field vibrations only in a particular direction in a plane, restricted all other vibrations by that material. That material is called polaroid or polarizer. So Polaroid is a material. It is a commercial thin sheets which make use of the property of selective absorption to produce the plain polarized light. Polaroid is a material which is used to produce plain polarized light. Plain polarized light. But Polaroid, which make use of a property selective absorption, which is used to produce plain polarized light. Simply we call Polaroid is a material which is used to produce the plain polarized light. How? When unpolarized light allowed to pass through the Polaroid sheet, light come out from the Polaroid, its light vibration only one particular direction. All other light vibrations are restricted by the Polaroid. For example, it is a Polaroid. See, ordinary source of light is an unpolarized light. Light vibration in all possible directions like this. In a perpendicular to the direction of propagation of waves. So arrow gives the direction of propagation of wave. But ordinary source of light contains light vibration in all possible directions, like electric field vibration in all possible directions. It is called unpolarized light. So any one ordinary source emits this kind of unpolarized light. This unpolarized light is allowed to pass through the Polaroid. Dear students, you see, Polaroid is a material which is used to produce plain polarized light. This unpolarized light is allowed to pass through the Polaroid. Light beam come out from the Polaroid. We observe the light beam come out from the Polaroid. See the light vibration, only one particular direction. This light vibration, which is parallel to the optic axis of the crystal. This is optic axis. See that optic axis and light beam come out from the Polaroid, that light vibrations both are parallel with each other. So all other vibrations in that unpolarized light are restricted by the Polaroid or polarizing sheet. So that's why this light come out from the Polaroid is said to be plain polarized light. Plain polarized light. So Polaroid is a material which is used to produce a plain polarized light, which is used to convert unpolarized light into plain polarized light. Okay. How we make the Polaroid? How we make the Polaroid sheet, or how we make the polarizer? So Polaroid or polarizer is a material. It's a thin sheet of a transparent material, which make use of the property of selective absorption, which is used to produce plain polarized light. So simply we call unpolarized light converted into polarized light. Okay. Now, in 1932, American scientist Edwin Land developed a thin commercial sheet of Polaroids. Thin commercial sheet of Polaroids. Who was discovered or who was developed a thin sheet of commercial transparent Polaroid? In 1932, American scientist Edwin Land developed a thin sheet of commercial transparent Polaroids. Okay. So, tourmaline crystal is the natural polarizing material. or natural polarizing material. Tourmaline crystal is one of the crystal tourmaline crystal Dear students, tourmaline crystal is a natural polarizing material. So, tourmaline crystal, which is used to convert unpolarized light into polarized light. It's a natural polarizing material. But polarizing material or polarize also make it artificial. Make it artificial. It was discovered, taken a large number of needle-shaped crystals of needle-shaped thin crystals of quinine iodosulfate. Why? Because we make the Polaroid artificially. How? Take a large number of thin needle-shaped crystals of quinine iodosulfate. Thin needle-shaped crystals. Crystals of quinine iodosulfate. So we make it Polaroid or polarizer artificially. Thin needle-shaped crystals of quinine iodosulfate. Taking these large number of thin crystals of quinine iodosulfate arranged in such a way with the optics axis parallel with each other, it is a tightly packed in between thin transparent plastic sheet. It will serve as a good polarizer or good Polaroid. So how we make it Polaroid artificially? Take a thin needle-shaped crystals of quinine iodosulfate. Take this large number, arranged in such a way with the optic axis are parallel with each other, tightly packed in between thin transparent plastic sheet. It good serve as a Polaroid or polarizer. In this way, we make Polaroid or polarizer artificially. But in recent days, we make a newer type of Polaroids by use of thin film of polyvinyl alcohol. In recent days, we make it Polaroids by using thin film of polyvinyl alcohol. Thin film of polyvinyl alcohol. So this thin film of polyvinyl alcohol produces better polarization. So we use or we develop in recent days, we make it a Polaroid by using thin film of polyvinyl alcohol, which transmits the more plain polarized light, or that emergent light from these Polaroids by using thin film of polyvinyl alcohol produces more intense of plain polarized light and also act as a better polarization. or better polarides. So in this way, polaroid or polarizer is thin sheet of transparent material in which needle-shaped crystals are arranged parallel with their optic axis and tightly packed in between thin sheet of a transparent plastic sheet act as a good polaroid. And recent days, we make a polarides by using thin film of a polyvinyl alcohol, which produces or which transmits the more polarized light for better polarization. So in these polarides and also polarizer is a material which make use of the property of selective absorption, which transmits the light vibration only one particular direction, which is parallel to the optic axis and restricted all of the other vibration from the unpolarized light. It is one of the way to produce unpolarized light into polarized light. Okay. Next, we go to the another one, polarizer and analyzer. What is polarizer and what is analyzer? Polarizer. Polarizer is a device which is used to produce plain polarized light. Device which is used to produce plain polarized light. So what is polarizer? Polarizer is a device which is used to produce plain polarized light. For example, take one Polaroid. It is a Polaroid. It is a Polaroid. See, ordinary source of light emits a light waves, that light vibration in all possible directions, in a perpendicular to the direction of propagation of waves. These are the ordinary source of light emits a light waves. In that light wave, light vibration like electric field vibration in all possible directions in a perpendicular to the direction of propagation of waves. This unpolarized light is allowed to pass through the polaroid, passing through the polaroid. See the emergent light from the polaroid, that light vibration only one particular direction, which is parallel to the optic axis of the crystal. It is the optic axis like this. That light vibration come out from the polaroid. Light vibration only one particular direction in a plane, which is parallel to the optic axis of a crystal or optic axis of a polaroid. This light come out from the polaroid is said to be polarized light or plain polarized light. So this is a device, like a polaroid is a device. Here, polaroid is a device which is used to produce plain polarized light or polarized light. Then the device is said to be polarizer. Okay. See students, next I am taking one more polaroid. It is another polaroid. This is another polaroid. It is polaroid P1. It is another polaroid P2. See both the polaroid Arctic axis are parallel with each other. This is Arctic axis. So first polarized Arctic axis and the second polarized Arctic axis parallel with each other. Okay. If it is unpolarized like this, passing through the polarized P1, light vibrations come out from the first polarized only one particular direction in a plane which is parallel to the first polarized Arctic axis. It is called plane polarized light. Okay. Then this plane polarized light is allowed to pass through the second polarized, which is placed parallel to the Arctic axis of first polarized. What happens? Emergent light from the second polarized. Actually, this is a plane polarized light is allowed to pass through the second polarized P2. That second polarized Arctic axis and the first polarized Arctic axis parallel with each other. What happens? Emergent light from the second polarized. Yes, that same only one particular vibration in a plane polarized light is made to pass through the second polarized. That same the vibration is come out from the second polarized, because that light vibration which is parallel to the Arctic axis of the second polarized, immediately second polarized allow that vibration passes through it. So emergent light from the second polarized, it is also plane polarized light. Plane polarized light. Okay. See, in case unpolarized light is allowed to pass through the first polarized, in unpolarized light, the light vibration in all possible directions. You notice that diagram? In a perpendicular to the direction of propagation of wave is which is allowed to pass through the first polarized. See, emergent light from the first polarized, that light vibration only one particular direction in a plane which is parallel to the Arctic axis of first polarized. It is the plane polarized light. Plane polarized light. Why? Light vibration only one particular direction in a plane which is parallel to the Arctic axis of the first polarized. Okay. The same vibration, that plane polarized light is allowed to pass to the second polarized P2. Actually, second polarized and the first polarized which is kept parallel with each other. Why? Both the Arctic axis are parallel with each other. Then the plane polarized light is allowed to pass to the second polarized. See, the emergent light from the second polarized, light vibration only one particular direction. The same vibration will allowed to pass to the second polarized. Then the vibration come out from the second polarized, which is parallel to the Arctic axis of the second polarized. Still, that light come out from the second polarized, still plane polarized light. Okay. If first polarized get constant, Arctic axis get constant, don't change the position of the first polarized, but the second polarized is rotated like this. So axis of rotation is the direction of propagation of light is keep us a axis of rotation. On basis of the axis of rotation, then second polarized is rotated like this. What happens? Emergent light from the second polarized. Emergent light beam intensity varies. Intensity of light vary. Why? Because now second polarized is rotated like this. We keep direction of propagation of light, keep as an axis of rotation. Second polarized is rotated. Emergent light beam intensity is decreases. If exactly second polarized Arctic axis is a perpendicular to the first polarized Arctic axis. And that particular direction of orientation see like this. Arctic axis is perpendicular. This is Arctic axis. See, first polarized optic axis like this. Second polarized P2 optic axis like this. There is no light come out from the second polaroid. No light come out from the second polaroid. So, second polaroid optic axis parallel with the first polaroid optic axis. Light come out from the second polaroid is there. Intensity is maximum. Intensity is maximum. If first polaroid get constant, second polaroid is rotated like this. Emergent light beam intensity goes on decreases if exactly second polaroid optic axis and the first polaroid optic axis right angles to each other are perpendicular direction. No light come out from the second polaroid. Intensity of emergent light beam from the second polaroid is 0. That's why second polaroid, which is used to examine the light, is polarized light or unpolarized light, is examined with the help of second polaroid. That's why second polaroid is called analyzer. Analyzer. So analyzer is a device which is used to examine whether light is plane polarized light or not. We can examine with the help of analyzer. So polarizer is a device which is used to produce plane polarized light, but analyzer is a device which is used to examine whether light is plane polarized light or not. Okay. Analyzer is a device which is used to examine the light is plane polarized or not. So dear students, we discuss about polarizer and analyzer. Polarizer is a device which is used to produce plane polarized light. Analyzer is a device which is used to examine whether the light is plane polarized light or not. Okay. Plane polarized light and partially plane polarized light. Plane polarized light. What is plane polarized light? See, I take two polarides. First one polaroid P1, another polaroid P2. Both the polaroid optic axis parallel with each other. So both the polaroid optic axis parallel with each other. See, unpolarized light. Unpolarized light vibration in all possible directions in a perpendicular direction of propagation of wave. Okay. This unpolarized light is allowed to pass through the first polaroid. Emergent light from the first polaroid, light vibration only one particular direction. Light vibration only one particular direction. In a plane which is parallel to the optic axis of the first polaroid. It is called plane polarized light. Plane polarized light. Okay, why it is called plane polarized light? Because light vibration only one particular direction can play, which is parallel to the arctic axis of the first polaroid. Okay, this plane polarized light is allowed to pass to the second polaroid. Actually, second polaroid arctic axis and the first polaroid arctic axis parallel with each other. This plane polarized light allowed to pass to the second polaroid. See, emergent light from the second polaroid, that light vibration is the same. Okay, it is also still plane polarized light. Polarized light. See, before this experiment, intensity of unpolarized light is high. That is, intensity of unpolarized light is high. This intensity of unpolarized light I is allowed to pass to the first polaroid. Emergent light beam intensity of plane polarized light is I divided by 2. Half of the intensity of unpolarized light are absorbed by the first polaroid. See, very, very important concept. You have clearly observed this concept. Unpolarized intensity I. This unpolarized light is allowed to pass to the first polaroid. That light vibration only one particular plane, only one particular direction. It is called plane polarized light. Plane polarized light intensity I divided by 2. Remaining half of the intensity of unpolarized light is absorbed by the first polaroid. So this plane polarized light is allowed to pass to the second polaroid. That light vibration is the same, only one particular direction, which is parallel to the arctic axis of the second polaroid. That intensity of emergent light from the second polaroid also I divided by 2. Why? Both the polaroid arctic axis are parallel with each other. But in the case, first polaroid kept constant, keep in the same position, but the second polaroid is rotated, keep the arctic axis, direction of propagation of light is the axis of rotation. Now rotate the second polaroid. See, the emergent light beam intensity goes on decreases. Then finally, second polaroid arctic axis is perpendicular to the first polaroid arctic axis. It is the first polaroid arctic axis. It is the second polaroid arctic axis. Both is exactly right angles to each other. No light come out from the second polaroid. No light come out from the second polaroid. Intensity becomes 0. So then the light is said to be plane polarized light. If a second polaroid is rotated from parallel to first polaroid arctic axis, emergent light beam intensity is maximum. If a second polaroid is rotated from axis parallel to perpendicular, emergent light beam intensity is decreases and reduced to 0. So therefore, when a second polaroid is rotated from 0 to 90 degree in that orientation, emergent light beam intensity from the second polaroid is maximum to reduced to 0. Then the light is said to be plane polarized light. Then partially plane polarized light. If second polaroid is rotated from arctic axis parallel to the first polaroid to the arctic axis perpendicular to the second polaroid, emergent light beam intensity is maximum to minimum, not is equal to 0. Because if arctic axis parallel to the first polaroid, maximum intensity of light is there from the second polaroid. But second polaroid is rotated, emergent light beam intensity from the second polaroid is decreases from maximum. If arctic axis of second polaroid is perpendicular to the first polaroid, certain amount of intensity of light is come out from the second polaroid. That light vibration not completely restricted by the second polaroid arctic axis. Certain minimum intensity is exists from the second polaroid. Okay. So then the light passing through the second polarity is said to be partially plane polarized light. Why? That emergent light beam intensity from the second polarity is maximum to minimum not is equal to 0. So that light passing through the second polarity is said to be partially plane polarized light. Okay. Dear students, go through all topic. What is polarization? Polarization is a phenomenon. Then what is polarized light? What is unpolarized light? What is plane of vibration? What is plane of polarization? Then what are the techniques we adopt to produce unpolarized light into polarized light? There are 4 techniques we use to convert unpolarized light into polarized light. Already I completed polarization of light by selective absorption method. Then what is plane polarized light? What is partially plane polarized light? Then what is polarizer and what is analyzer? Go through all topics in your textbook. Take the proper notes. It will be helpful for future. Thank you, students. Thank you, one and all.